So let's work through some examples out of 5.2. So to begin with, we're just asked for the degree of this polynomial and to determine is it a monomial, binomial, or trinomial. So let's start with the second part. So a polynomial is made up of terms. Terms are things added or subtracted. So we have this term plus this term plus this term. So this one has 1, 2, 3 different terms. If it has 3 terms, that's a trinomial. Binomials have 2 terms, monomials have 1 term. If it has more than 3 terms, we just call it generally a polynomial. All of these are polynomials, whether it has 1, 2, or 3 terms, but we don't really classify things of more than 3 terms. So now let's look at the degree. If we only have one variable in a term, then the exponent of that variable is the degree. So if we have 2 variables in a term, we add their exponents to determine the degree. So for the first term, we have x to the 8th, y to the 1st, so 8 plus 1. The degree of this term is 9. This term, we have x to the 3rd, y to the 1st, so 3 plus 1, the degree of that term is 4. Here we have x to the 3rd, y to the 5th, 3 plus 5 is 8, so the degree of that term is 8. So the degree of the polynomial is the degree of the largest term. So the largest degree that we have out of any of the terms is 9, so this is a 9th degree polynomial. Now, if we only have one variable in our term, then we determine the degree of each term by that one exponent. So this degree is 2, this degree is 3, this degree is 1. So for this example, this would be a 3rd degree polynomial. So that's how we determine the degree of a polynomial, the degree of the term that has the largest degree. Okay, so the next part, they give us polynomials and they give it in function notation. And remember, with function notation, if we're asked to do something like p of 6, this doesn't mean p times 6. P tells us which of these two functions we're using. Are we using this one or are we using this one? So we're going to use that one. So the formula for our function that we're using is x squared plus x plus 3. The number in parentheses tells us what we're plugging into that formula. So in our case, we're plugging the number 6 into the formula called p. So as we mentioned in 5.1, anytime we plug a number into a formula, we want to put a parenthesis around it. So we have the number we're plugging in that needs to get squared. Then we're adding the number we're plugging in, and then we're adding 3. So our number squared plus our number plus 3. Our number squared plus our number plus 3. So we're using our formula and plugging in a 6. So now we just need to do order of operation. So inside parentheses, there's nothing to do, so we do exponents next. 6 squared, so 6 times 6 is 36. Bring down the other two terms. Now we just have adding, so we can go left to right. 36 plus 6 is 42. 42 plus 3 is 45. So we just evaluated a polynomial function at a specific number. Now the next problem wants us to simplify this polynomial. We have 1, 2, 3, 4 terms right now. So to simplify this, we're combining like terms. When we add or subtract, we can only add or subtract things that are like terms, and to be like terms, they have to have the same variable, and that variable has to have the same exponent. Those are like terms because they multiply to the same power. So if you watch the lecture videos from this section, then the way we combine these is we combine their coefficients. We have 0.6 of these things weigh 1.4 of those things, whatever they are, whether they're y's or y squareds. So we could do that by hand and say, since we have different signs, we subtract, and the way we subtract is we put the larger number on top, line up the decimals. Can't take 6 from 4, so we have to borrow. 14 minus 6 is 8. Bring our decimal down. Take the sign of the larger number. Negative 0.8 is what we get when we subtract them. That tells us how many y squared we have. Now, these are like terms as well. So combine those. We have opposite signs, so we subtract them. 9.9 minus 1.6. Bring the decimal down and then just subtract. Sign of the bigger number is positive, 8.3. Now I'm fine with you doing the adding and subtracting with your calculator instead of having to do it by hand like this. But that was just a little reminder, how do we subtract decimals? But the main emphasis here is combining like terms. So let's do another one. So we have quite a few terms here. So we need to begin by determining which terms are like terms. So the first term has an a to the second. If we look, there's another term that has an a to the second, and that's that one. So those are alike. So I'm going to copy the problem down and just rearrange. Remember, with addition, addition is commutative. And technically, subtraction is not commutative, but if we keep the sign that goes with the term with it, it is still okay to move it around. So, a squared and minus 7a squared, those are alike. The next term we see has an a to the first and a b to the first. Well, we have another one of those. So let's copy those. Minus 6ab, minus 5ab, those are alike. The next term has a b to the second. Well, we have another one of those. So we have 6b squareds, and then we also have 9b squareds. So we just collected our like terms together so that when we go to add them or subtract them, it's easier to see what things are alike, what things are different. So those are alike, so we combine their coefficients. 3 minus 7. So the same signs, we add the numbers, take the sign of the bigger, and that tells us how many a squared we have. Here, those are both ABs, so if we want to know how many ABs do we have minus 6, and then we have minus 5 more. You might say we owe somebody 6, and then we end up owing somebody else 5, so how much do we owe in total? Same signs, we add the numbers, take the sign of the bigger. And then these are alike. We have 6b squareds, and then we have 9 more. So how many b squareds do we have? Well, 6 plus 9. So we have 15 of those b squareds. Okay, so as we go on, this one we're doing a subtraction. We're taking away this parenthesis. Remember, if we have a number in front of a parenthesis, that number gets distributed to each of those terms. So 3x would get multiplied times 2, and 5 would also get multiplied times 2. That's known as the distributive property. And we'll talk about that more later on. But when we have a negative in front of a parenthesis, we can think about having an understood 1 there. So we're going to do negative 1 times that first number. So negative times positive is negative. Of course, 1 times anything is that amount. Negative times negative is positive, and 1 times 4 is 4. Another way of looking at this is a negative tells us that we want the opposite. So this negative says do the opposite of that parenthesis. So we bring our 10x down and we want the opposite of 12x. Well, the opposite of 12x is minus 12x. And we also want the opposite of minus 4. Well, the opposite of minus 4 would be positive 4. So either way, we end up with the same signs, but essentially what a lot of people remember is if there's a negative in front of a parenthesis, it changes each sign on the inside, and we just bring those signs down. So now we need to combine like terms. So the first two are like terms. So if we want to know how many x's there are, negative 2 x's and bring down the plus 4. Those are not like terms because one has an x, one doesn't, so that's as far as we go. Now if we do this one, to add these two polynomials, we're going to add that. So since there's a positive in front of the parentheses, we don't change the sign. We don't want the opposite of that. We just want to add that. So we're adding 3y squared. We're adding y. And we're adding negative 4. So now let's rearrange, get like terms beside each other. So we have the y squared terms, so minus 9y squared and 3y squared. We have terms that have y to the first, so we have a minus 9y. And if it helps you, remember that the understood coefficient of y is a 1, so we have plus 1y. And then we have a minus 4. So we put these together to see the y squareds. We have minus 9 plus 3. Negative 9 plus 3 is negative 6. These are y's, so to see how many y's we have negative 9 plus 1, which is negative 8. And then we don't have a term to combine the negative 4 with, so bring it down. Now, if you rearrange these in different orders and put the y's first and then the y squareds, that would be okay. For example, if you wrote it minus 8y minus 6y squared minus 4, that would be acceptable. Normally, we put them in order on descending powers. So y to the second, y to the first, and then no y's. So let's do another one. So here we have 3 polynomials. We're adding the first 2 together, and then we're going to take away the next one. So we have 4x squared plus 9x minus 5. We're going to add 2x squared. We're also going to add 5x, and we're going to add 18. You remember what this negative does. It changes both signs. We're going to take away 6x squared, and we're going to take away minus 15. If we're taking away minus 15, minus a negative, we're really adding. So both signs got changed. Now let's just group our like terms together. We have 4x squared. We have 2x squareds. And we have minus 6x squareds. We have 9x's to the first. We have 5x's to the first. And then we have some constants, some numbers that don't have a variable. So we have minus 5 plus 18 plus 15. So put these together. All the x squareds, we have 4 plus 2 is 6, and then we're taking away 6. 6 minus 6, well, we really have no x squareds. Well, no x squareds, that's just 0. We have 9x plus 5x. 9 plus 5 is 14, so that's how many x's. And then we can combine those. So just go left to right. Negative 5 plus 18, or you can put that in your calculator. That gives you 13. And then add 15 to it. 13 plus 15. And that'll be 28. Those are not like terms, so we can't go any farther, so stop there. Now this is essentially the same type of problem. We're combining polynomials, but it's also a little bit of a word problem. They ask us to subtract this polynomial from that one. So we have to ask ourselves, what are we taking away? This is what we're starting with, and we're taking this from that. So we have 3x squared plus 7x plus 4, and we're taking away 8x plus 9. Now notice that I put that in parentheses. If we would have not put parentheses around the 8x plus 9, this would say we're taking away 8x because that minus is only affecting the 8x, but then we're adding 9. And that's not what we want. We want to take away this whole expression. We want to take away all of that. So if we put it in parentheses, this says subtract that polynomial. So drop the parentheses, so 3x squared plus 7x plus 4, subtract 8x, so minus 8x, subtract 9, so minus 9, and combine like terms. Now, after you do this for a while, you may or may not rearrange things. We have 1x squared term, so bring it down. We have 7x minus 8x, so if we combine those, 7 minus 8 makes for negative 1. X, of course, we don't have to write the 1, because 1 is an understood coefficient. And then we have 4 minus 9. 4 minus 9 is negative 5. So we could write it that way, or as I mentioned, we could leave the 1 off, and those mean the same thing. If you type it in that way in MyMathLab, that's fine. Or if you write it that way on the test, that's okay. Traditionally, you would write it the bottom way, but either one of those are okay because they're equivalent to each other.